Video on lesson 921. We don't always do 921, so some years we do this, some years we don't, just depending on where we're at. You can see the big thing here is that it's an inequality sign instead of an equal sign. So if you remember from integrated 1, when it's an inequality sign, that meant we went with like a dotted line and we either shaded above or below it. And if it was like a less than or equal to, we went with the solid line, and again we shaded above or below it. So that's kind of what we're looking at in this lesson today, except for we're now going to have a parabola that will either be a dotted parabola that we shade above or below. That's really what we're looking at here. I've jotted down 952, 953, A, B, and C because I'm going to go to a coordinate plane and I'm not planning on coming back to this page. So I'm going to do these 4 problems on a coordinate plane. So hopefully you have these things jotted down and we'll follow along. So 952, the problem was x squared plus 2x plus 1 is less than 4. I think the easiest thing to do is ignore this for right now. We do not want to mess with this inequality sign. We're just going to call it an equal sign, and we're going to come back and worry about this later. I would subtract 4 from each side, and I would get x squared plus 2x minus 3 is equal to 0. At this point, I can put it on the diamond. I get negative 3 and 2. I get 1x. It looks like 3 and negative 1 are going to work. 3 times negative 1 is negative 3. 3 minus 1 is 2. So my equation is going to be x plus 3, x minus 1 is equal to 0. So from when I'm in standard form, I can get my y-intercept. If I plug in 0 for x, I'm sorry, that should be an x. If I plug in 0 for x, I get negative 3. I apologize for that, missing that x. And if I go here, I can get my x-intercept at negative 3 and positive 1. At this point, if you're thinking, I know my axis of symmetry is negative 1, and I'm going to plug that in, you're right. However, I'm just going to complete the square, so there's no doubt. I'm going to get rid of the number I don't want, so I'll add 3 to both sides. I'll take half of b squared. Well, first I'll factor out the 1, which does nothing. Half of b squared, half of 2 is 1. 1 squared is 1. Anything in here is times 1, so I'll just add 1. I get half of this. I'm sorry, I get the perfect square of this, which would be x plus 1 squared equals 4. And now I'll just subtract 4 from each side to put it together. And you can see I get negative 1, negative 4 as my vertex. Because of symmetry, I should have a point here, right? That thing folds in half right there. Now I will go back and look at my absolute value. I'm sorry, not my absolute value, at my inequality, and it does not say equal to, so this is going to be a dotted line. So I'm going to get a dotted parabola. And the last question is, do I shade above it or below it? And there's a lot of different ways. Remember, back to integrated 1, we said if like y was less than 3x plus 1 and we had the y on the left, you could just decide if it was above or below it. But here we don't really have a y, and it can be a little bit tricky. So I think my advice to you would be to plug the point 0, 0 in to this equation, and let's just see what we get. And if 0, 0 is true, we'll shade that side. If 0, 0 is false, we'll shade the other side. So if I plug in 0 for x, there's no place to sub in for y. So actually I should probably go down here and do that one, but let's see, 1 is less than 4 is true. I would have shaded that side, but let's go here. Actually, I think I'm better off. I apologize. Let's go here. This is actually going to be plugging in for y. So we'll say 0 squared plus 2 times 0 minus 3 is equal to 0. So actually is less than 0, right? I should have gone up here at this point. This would have been a less than y. So is negative 3 less than 0? Negative 3 is less than 0. That means that we're going to shade the 0, 0 side. Again, we could have plugged in y there, and it would have come out y is greater than, and that would have told us to shade above it as well. So pretty confusing. I would just say plug 0, 0 into the equation and see what you get. We'll do a couple more of these, and hopefully this will make a little bit more sense as we go. I'm not sure what's going on here. Let's try and open a new one and see if that actually makes it faster. Okay, so let's go to 53a. 53a is x squared plus x minus 12 is less than 0. And again, that's also serves as a y. But so I have negative 12, so I can go down here, and I know that I have something at like negative 12 down here is my y-intercept. So kind of off the page there a little bit. I will go x squared plus x minus 12 is equal to 0. I'll put this thing on a diamond. I get negative 12 and 1 with an x. So it looks like a 4 and a negative 3. 4 times negative 3 is negative 12. 4 minus 3 is 1. So I get x plus 4, x minus 3. So I have negative 4 and positive 3. And again, a y-intercept way down there somewhere. Next thing, I can complete the square here. Completing the square here is not going to be fun because that's not an even number, and I don't want to mess with fractions. So I'm just going to work my way in to find where my axis of symmetry is, and it appears to be at negative 1/2, right? If I go 1, 2, 3.5, half, 1, 2, 3. So it looks like x is going to equal negative 1/2. So what happens if I plug in x equals negative 1/2 into this equation? So I get negative 1/2 squared plus negative 1/2 minus 12 is less than 0. And I'm just looking for where my vertex is. Negative 1/2 squared is positive 1/4. Minus 1/2, I'm going to call this minus 2/4 just so I have a common denominator. And minus, again, I'll say minus 48 over 4 is less than 0. Again, just the idea here is that negative 12 is the same here but as negative 48 over 4, but I have this common denominator. So 1 minus 2 is negative 1 minus 49 over 4. So that's going to end up being like negative 12 1/4. So way down here somewhere is going to be my vertex at negative 12 1/4. So it sort of goes off the screen. Now I will integrate. You can see it's a dotted line. So just sort of do the best I can here because I go off my graph, which is fine. Come back up. And I will go to this equation right here again. Remember, I can substitute that 0 in for y. So I'm going to plug in 0.00 because it's clearly not on the point there. So I get 0 plus 0 minus 12 is less than 0. Is negative 12 less than 0? Negative 12 is less than 0. So again, I want to shade this part of the parabola. If we go ahead and get a new coordinate plane, we can do 53b. 53b is negative 2x squared plus 10x is greater than or equal to 7. Again, I'm going to change this into an equal sign. Subtract 7. I get negative 2x squared plus 10x minus 7 is equal to 0. So I have a y-intercept at negative 7. I don't know if you can hear my dog barking, but he doesn't like the neighbor dog. So he's letting him know what's up. Actually, I guess at this point, I should try my diamond. I get a positive 14. Yeah, this is going to work out really ugly. I'm just going to jump straight to the quadratic formula. I don't even want to mess with the diamond here. The diamond might work, but it's going to get messy, and I can tell. So I'm going to say negative b plus or minus the square root of b squared minus 4 times a times c. All of that is going to be over 2 times a. Hopefully you guys remember that. I get negative 10 plus or minus the square root of 100 A negative times a negative is a positive times a negative is a negative. 8 times 7 is 56 over negative 4. I get negative 10 plus or minus the square root of 44 over negative 4. At this point, it's probably a good idea to reach for a calculator because I'm going to get two things. I'm going to get negative 10 plus the square root of 44 over negative 4. And I'm going to get negative 10 minus the square root of 44 over negative 4. I should have put a negative here, sorry. Okay, so again, I'm going to go to calculator here. Uh-oh, pushed the wrong button. That jumped on me there. So if I go here, if I go negative 10, remember you got to go negative 10, not minus 10, plus the square root of 44. I'm just going to enter here, and then I'm going to divide by negative 4. So you can see I get 0.841. And go back over here. I'm going to go negative 10 minus the square root of 44. And if you're wondering why I am hitting enter here rather than dividing it by negative 4, it's because I need to do the whole top and then divide the top by the bottom. Where if I put just divide by negative 4, I run into the possibility that I could screw this up rather easily, order of operations. So that, I'm going to divide that by negative 4, and I'm going to get positive 4.15. So I'm going to have an x-intercept at like 4.15 and at like was that one positive or negative? They're both positive? Oh, yeah, that makes sense because it's going to open down. I was confused for a second, like wondering what was going to happen, but it's going to open down. That's why it looks the way that it does. I kind of missed that it has a negative 2x. As far as completing the square here, I'm going to complete the square to get the vertex. So I have negative 2x squared. I'm just going to grab on right here since I already have it by itself. So negative 2x squared plus 10x is equal to 7. I'll factor out a negative 2. If I do, I get x squared minus 5x. Hopefully we see that, right? Negative 2 times x squared is negative 2x squared. Negative 2 times negative 5 is positive 10x. And then what I'm going to do is grab half of this. So what is negative 5 divided by 2 squared? Well, hopefully everybody sees that it's just going to be negative 2.5 squared. So I'll just say, what is negative 2.5? I'll say, what is negative 2.5? The whole thing needs to be squared, so I should probably put it in parentheses. You can see I made a mess of this. Squared is going to equal positive 6.25. So I'm going to add 6.25 here. But again, that's this. Everything in here is times negative 2. So I'm actually subtracting 13.5. So I will get negative 2x, and you can complete your square on this, but it's going to be x minus 2.5 squared equals negative 6.5. Then I'll add 6.5 to each side, and I will get negative 2 x minus 2.5 squared plus 6.5. So my vertex is going to be 2.5, 6.5, 1, 2.5, 6.5. And it's going to open down and be steep, which makes a lot of sense based on what I'm looking at. Also, because of symmetry, I'm going to have a point here as well. So now I'm going to go ahead and look at this. This says equal to, so this is going to be solid. So you can see it's not the most difficult thing, but this is not the easiest lesson you're going to learn this year, that's for sure. All right, if I plug 0, 0 into the inequality over here, again, I will do it where I have it right here. So I will clean this up a little bit. You can see if I subtract 7 from both sides, it would be greater than or equal to y. So I'm going to go in and I'm going to plug in 0 for x and for y. Again, the reason I plug in 0, 0 is it's so easy. 0 squared times negative 2 is 0, plus 10 times 0 is 0, so I get negative 7 is greater than or equal to 0. Is negative 7 bigger than 0? It is not, so I would shade this. I'm not going to shade 0, 0, 0, 0. It turns out to be false. I get a feeling this is a long video that no one will ever watch. All right, finally, let's go ahead and end this lesson with 953C, which is going to be great because it's the absolute value of x minus 2 is greater than 7. So this will be way faster and way easier. It's just so easy to graph these things. So again, my A is assumed, it's like a 1 here with a plus 0 here. So my starting point is going to be 2, 0. And from there, actually, I take it back. I'm totally wrong. I lied to you about how easy this is going to be. Again, what I should do is I should make this thing equal to 7 before I start. Now I'll subtract 7 from each side, and I'll get the absolute value of x minus 2 minus 7 is equal to 0, or y. And now I'm going to start at 2, 7. I'm sorry, 2, negative 7. What am I doing? Bonkers. 2, negative 7. I said this would be easy. I did real well with it. My change is up 1 over 1, so it's going to look something like this. Again, it is going to be a dotted line, so I'll just go like that. It's not equal to, so I can just sort of do that. And then again, I could check point 0, 0. Or 0, 0 is always going to be the easiest point to check. And I think the easiest, I'm going to check it right here when it is absolute value of x minus 2 minus 7 is greater than y. So if I plug 0 in, I get negative 2. The absolute value of negative 2 is 2, so 2 minus 7 is greater than 0. Is negative 5 greater than 0? It is not, so I'm going to shade the other side. Boy, I don't think this translated very well to a video. I hope you were able to follow it. If you weren't, I apologize. I will tell you what not a bad trick is on stuff like this, is to hop over to Desmos and double check your work and make sure that you're getting it right, because that would be one way to sort of confirm it. All right, have a good one.